Number 16, determine the oxidation states of the elements in the following compounds, and we have E. So we need to find the oxidation states of both magnesium and silicon in Mg2Si. So I'm just going to rewrite it over here. I got oh, that's an ugly M. Mg2Si. Yikes. And what we have to do is we just have to find the states. Now, I talk about oxidation states fully in number 16A, the start of this set. So if you want to go back and watch 16A, if you haven't, to get kind of more context, you can do that. The playlist button will be at the end of this video in like the, whatever it's called, the end screen or something. Yeah, as you can see, I'm such a YouTuber. I know all the fancy words. But, so yeah, you could check that out there. But let's just do a run through. Now with these, with compounds that have two elements, right? I have magnesium and silicon. What you're going to do is you're basically going to do your work here. And then once we have what we think are the oxidation states of the Mg and the silicon, we will then check what the trend is. And if our answers match the trend, then we're good. But if our answers don't match the trends, we have to do a little, something to make it work. So let's get started. Remember when we made compounds, right? In that case, we took the charges that were given to us and we crisscrossed them down to get the compounds. The charges that we took were the oxidation states. So now all we have to do is just take the subscripts that are in the compound and crisscross them back up to get the charges or the oxidation states. I say oxidation states or charges, they both mean the same exact thing, right? So let's see, I have Mg2 and then it's silicon 1, right? There's one silicon here. But now here are my two numbers. Let's crisscross them up. The 2 down below here crisscrossed to tell me that I had silicon being a -2. And I put a -2 because remember, the one at the end is always the negative charge. It's just how, normally it is. Positive comes first and then negative in your ionic compounds. And then we had a 1 down here. This crisscrossed up to tell me that magnesium was a +1. Okay, so let's see what's going on. Mg was a +1 charge, right? And silicon was a -2 in our answer. Let's see. Magnesium is over here. Magnesium on the trend is telling me that it's a +2. It can't be a +1. So this one, Let's check out silicon. Silicon is all the way over here. If I look up top here, silicon can either be a +4 or a -4, depending on what the situation is. So, not a -2. What are we going to do? This is where we have to tweak it a little bit. Now, remember, ionic compounds are always in the simplified form. So are in simplified form. So if you have those numbers that you could break down, ionic compounds are going to do them. So you just have to match what you want up here, right? They told me that magnesium was a 2+, so I have to times 2 to get to the +2. But if I do that, I have to be fair. I have to go to the silicon and I have to times it by 2 as well. So now this is a -4. And there are your charges. So Mg is now a +2. That's the oxidation state. And maybe I'll just bring this over a little bit because I want to kind of write a little bit down. And then silicon was a -4. Now, could we have just done the trend like, okay, magnesium +2, silicon -4? Sure. But I want you guys to get into the habit of maybe doing the crisscross because maybe there's an example on the test that your teacher or professor is trying to trick you on. Always do your work first and then just check. So what do these actually mean? We'll just quickly run through it. That when this compound came together, each magnesium became a +2. This means that you actually lost 2 electrons. The plus means lose because electrons are negative. If you're becoming more positive, you lost negatives. And then the opposite happened for silicon. Each silicon gained 4 electrons. So it gained 4 because if you're more negative, you gained electrons, which are negative. So just keep in mind and just write this down or just keep saying it over and over and over again. Pluses really mean lose. Negative really means gain because you're talking about electrons who are negative. Okay? So these are your oxidation states. Yay! Let me know in the comments what you thought, guys. Give this video a like and a thumbs up or, whatever. And subscribe to the channel if you want. That would help us out greatly. And it gets the word out that, this service exists for you guys. And we love helping you guys out. It's quite thrilling to see the sub number rise. And that's fun. But anyway, I hope you guys are doing well. All right? Keep working hard. Chemistry is fun, and I'll see you guys all in the next video. Bye-bye.